Hello, welcome back. Today let's try to solve another Leetcode problem from the Leetcode Daily Challenge 86, Partition List. So we are giving a linked list. So we're gonna output another linked list, but it should have some conditions. So the partition, should be like this. The node less than x come before the node greater than or equal to x, but at the same time, you should keep the order of the node. Now let me explain the descriptions. For example, we have example 1. We have 1, 4, 3, 2, 5, and 2, and x is 3. So it means if the value is less than 3, should be at the left side of the 3. If the, this is the only condition. For example, this 2 and 2 is less than 3, so it should go to the left side. But we need to keep the original order. This means the original relative order is 1 to 2. So here is 1 to 2. After that, we should also keep the values which is bigger than 3, 4, 3, 5. So here is 4, 3, 5. So we should also keep this in relative order at the, if the value is at the right side. For example, this 1 to 2 is less than 3 at the left side. And then at the right side, we should also keep the relative order. It should be 4, 3, and 5. How should we do this? You may think maybe we can do it in 2 loops. So for example, for the first loop, we're going to check the value. If it is less than 3, we're going to just prepare the value, use a dummy node pointed to 1, 2, and 2. So this is the first iteration. Because in this way, we can keep the relative order. And then we're going to have a second loop. We just check the values is more than and equal to 3. And then we linked it to 4, 3, and 5. Now we return our result. Because if we need to keep the relative order, normally we can use a 2-pass to solve the problem. Now let me write the 2-pass method to solve the problem. So we call it a 2-pass. Now let's prepare a dummy node. So the dummy equals to p pointer should equal to list node. Why we prepare a dummy? Because this is can avoid many operations. If you don't use a dummy, what if there's no node? How should you return? A lot of operations you have to check. If there's a no node, it means a none. You have to check this none. If you prepare a dummy, you can always return the dummy.next because the dummy will be fixed, and this p pointer will be shifted according to our result. This p pointer just needed to connect each of the node, and then the p pointer finished its operation. We just needed to return dummy.next because the p pointer has already pointed to a none. It means we've already used the p pointer. Then we return dummy.next. So this is the basic initialization for our pointers. Now we're going to prepare another pointer q, so equal to head. Because we are going to use this head to check the values if it is bigger than 3 or equal to 3 or smaller than 3. But inside the node, this dummy node should point it to the head. So we're going to give a 0 and head. This 0 doesn't matter. It is just a value because we will not use it because we're going to return dummy.next. But this head is important because we're going to point this dummy node to the head, to the first node 1, pointed to this node. Then we are going to use 2-pass to solve the problem. So while head, now we are going to use head. After that, we're going to use another pass. So for another pass, because the head cannot be used, it has already pointed to a none. Now, for the second pass, we're going to use this q pointer. So this is why we use a q equal to head, because we will use it later. Now let's try to loop through the head. We're going to check the values from the node. If head.val less than the value x, now the p pointer dot next. From the beginning, the p pointer pointed to the dummy node. Now it will point p dot next. It will connect it to another list node, so which is the list node head dot val. Because it is less than x, we can connect it directly. So this is actually the first pass. After that, we're gonna shift the p pointer to p dot next, and no matter we check this head value or not, the head pointer should always be shifted to the next. This means it's just a loop, so the head should equal to head dot next. So this is the first loop. Now we are going to use the second loop. The first loop just finishes like this. The p pointer pointed to the dummy pointer pointed to 1 and pointed to 2, pointed to another 2, and then it pointed to a none. So this already finished the first loop. Now we are going to use the second loop because it should not point to none. It should point to this number 4. This is not 4. Now we are going to use the second loop. Actually, it's the same. Let me copy the code from here. But here we cannot use the head anymore because the head pointed to a none. We should use another pointer from the beginning of the head. It's also pointed from the beginning. So we're going to use a q pointer. And we're going to check the q.val. If this is more than and equal to x, it means our p pointer here is still the p pointer because p pointer will connect it to this node 4. If p pointer should equal to p.next, and here the value should q.val, and last the q should be updated to q.next. You can see that it's exactly the same. Just the conditions is different. The head.val less than x, and this is a q.val more than or equal to x. And for this p pointer, it will always be shifted to the next. And the q pointer will be shifted to the next. After finishing this second loop, second pass, it means all the node has already been connected like this. We just need to dummy.next. Now let me run it to check if it really works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Actually, the time complexity is just O(n) because we used the 2 pass. It's O2n. 2n equals to O(n). Thank you for watching. Let's wait for the result. It's a little bit slow. Yeah, but just to prove everything is right. Yeah, you can see it passed and it's pretty fast. Thank you for watching. See you next time.